Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Today we are going to discuss about electric current. Electric current. So, electric current is nothing but the rate of flow of charge, the net charge crossing through unit cross section area. So, electric current we discussed. Okay, so I equal to Q by T. Electric current, the rate of flow of charge, electric current, electric current, electric current, electric current, CBSE grade 10 physics, electric current, CBSE grade 10 physics. Okay, so CBSE grade 10 physics. La 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 la. So I equal to Q by T. So I equal to Q by T. So rate of flow of charge. Rate of flow of charge. I equal to Q by T. I equal to Q by T. So SI unit of current is ampere. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. No, actually this is the class for grade 10. It will be helpful for grade 12 also. Okay, so 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Okay, right? So here we can also take SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Right? Yes. Now here you can observe electric current. Electric current. Okay. So now inside of the conductor, so this I am taking the conductor. So will it flows only one electron? Magnetic effects of electric current I will teach. Okay, so you can go and check my playlist. So I explained many times once. Go and check the playlist. Okay, light reflection and diffraction. So check, see the playlist ma. Definitely I will explain. Still I will explain definitely. I will. So now I am explaining electric current. So magnetic effects of electric current and chapter human and colorful world. Those chapters also I'll explain. Okay. Surely I will explain. So because I am explaining now today electric current, one by one I will explain. Okay. So now you can observe here 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So charges are moving inside of the conductor. So charges are moving inside of the conductor. So will you say only one electron if it is flows? Will you say current is flowing? Will you say only one electron, two electrons? Only one electron, two electrons if it is flows, will you say current is flowing? No. Okay, so because many charges are moving inside of the conductor, many charges are moving inside of the conductor. So charge is nothing but, so it is quantized. So charge is a quantized. Quantized in the sense number of charges are moving inside of the conductor. Number of charges. So only one electron, two electrons. We are not saying that number of charges are moving inside of the conductor. Number of charges are moving inside of the conductor. That's why Q equal to Ne. Q equal to Ne plus or minus Ne. So why you are taking plus or minus Ne? Plus or minus Ne is nothing but positive charges are there as well as negative charges are there. Positive charges are there as well as negative charges are there. That's why I am taking here plus or minus Ne. Okay. So now quantization of charge. N I am taking, right? So number of charges are moving inside of the conductor. Number of charges are moving inside of the conductor. Number of charges are moving inside of the conductor. Okay. So now E is equal to 1.6 into 10 power minus 19 coulomb. Okay, so this value is very important. This value is very important. This value is very important. Okay, so that is on one electron how much charge is present. So the question is on one electron how much charge is present. On one electron, so 1.6 into 10 power minus 19 coulomb. Okay, in 1 coulomb how many electrons are present? 1.6 into 10 power minus 19. So 10 by 10 if you are taking, then you will get 10 by, so here 16 into 10 power minus 19. If you are taking 16, then 10 by 16 into 10 power 19. Then so if you do this one, so 10 by 16 if you do, you will get it, you will get the value. So 0.625 into 0.625 into 10 power 19. Then 6.25 into 10 power 18 electrons. So here in 1 coulomb, 6.25 into 10 power 18 electrons are present. So this value is very important. This value is very important. Okay. This value is very important. So make sure that so you are listening this one. Okay. Here now once again on 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 1 by 1.6 into 10 power 19. So 10 by 10. So 10 by 16 into 10 power minus 19. 10 by 10 is into 10 power 19. So 0.625 into 10 power 19. In 1 coulomb 6.25 into 10 power 18 electrons are present. Okay. So I hope it is very clear. So okay, done. Now electrical appliances will discuss. We will discuss electrical appliances. Electrical appliances. What are the electrical appliances? So first one cell, battery. First one is cell. This is the cell. So positive terminal, negative terminal. First one coming to the second one. Coming to the second one. So this is cell, battery. Battery. Third one is so switch. This is the open switch. Open switch. Open switch. Open switch. And coming to the fourth one is closed switch. Closed switch. Closed switch. Closed switch. And coming to the fifth one, resistor. 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 Coming to seventh, sixth one is rheostat. Rheostat. Either this one, see, rheostat we can also take rheostat. Okay, so here Hello, hi everyone. So I am Siva sir. So resistor. So this is the rheostat. Rheostat. Here once observe, this is cell, battery, open switch, closed switch, resistor, rheostat. Rheostat. Okay. So check once here. Cell, battery, open switch. So if dot is the difference between open switch and closed switch, only one thing. Dot only, nothing else. Resistor is a device which is used to oppose electric current. Resistor is a device which is used to oppose electric current. Rheostat is nothing. So the device which is used to regulate the current without changing the voltage source. Regulate the current without changing the voltage source. So rheostat is the device. Rheostat is the device which is used to regulate the current without changing the voltage source. Okay, coming to the seventh one. So ammeter I am taking. Ammeter is a device which is used to measure the electric current. So voltmeter is a device which is used to measure the potential difference. See here, ammeter will be connected in series combination, voltmeter will be connected in parallel combination. Coming to the ninth one, so here I am taking bulb. So this is the bulb. Okay, so here actually if you connect it, this is the bulb symbol. Okay, and tenth one wire joining, this is a wire joining, and 11th one is wire crossing. So this is a wire crossing. Okay, so cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, so bulb, wire joining, wire crossing. So these are the electrical appliances. Okay, electrical appliances. Now so we will discuss about electrical circuit. A continuous and closed path of. Sir, okay, sir, you are explaining all these points. Questions will come on this concept? Yes, definitely questions will come on this concept. So how they will ask? Till now I explained about electric current definition. Yes or no? Electric current, related to electric current definition I explained, and the electrical circuit. Okay, so till now whatever I explained, electric current I explained, electric current, and charge related to charge, positive charge, negative charge. So charges are moving, Q equal to plus or minus Ne, and one electron, how much charge is present in 1 coulomb, how many electrons are present. So related to this one they will ask questions, and related to electrical appliances also, how they will ask, how many marks they will ask. Okay, so first one is, what does an electric circuit mean? 1 mark question they will ask. Name the SI unit of electric charge. So MCQ's point of view also very important. So name the SI unit of electric charge. That is one point. And coming to how much is the charge on an electron? Can a charge less than this value exist here? Here you can observe. So I hope it is very clear. You can see. So what does an electric circuit mean? Name the SI unit of electric charge. And how much is the charge of an electron? Can a charge less than this value exist or not? Okay, so related to this one, and coming to the one more, define electric current and SI unit of electric current. Define electric current and SI unit of electric current. So that also they will ask. And state the relationship between 1 ampere and 1 coulomb. State the relationship between 1 ampere and 1 coulomb. So what is an ammeter and how it is connected in circuit? I already explained it. What is an ammeter? Ammeter is the device which is used to measure the electric current. Ammeter is connected in circuit, series combination. Ammeter is connected in series combination. And coming to the potential difference, so voltmeter is the device which is used to measure the potential difference. Okay, so related to these questions they will ask, and coming to the problems also they will ask. Okay, so related to problems also they will ask. And one more thing I said, so the charge possessed by an electron is 1.6 into 10 power minus 19. Okay. Coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. So I already explained this question. You can check here. So the charge possessed by an electron is 1.6 into 10 power minus 19 Coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. 1 ampere. So these questions they will ask. Okay. These questions they will ask. Okay, so this type of questions they will ask. And here discuss between terms electrical resistance and resistivity of the conductor. I will explain this one. Okay, done. So I hope it is very clear. Now we will go to the next one. Okay, so I'll explain one more. That's what that is electrical circuit. Okay, so electric circuit I will explain. Electric circuit, a continuous and closed path of an electric current. Electric circuit, electric circuit, electric circuit, electric circuit, electric circuit, a continuous and closed path of an electric current is known as an electric circuit. So here is this what is this one? Bulb, and I am taking here ammeter, and so here is the battery, and here I am taking here current is flowing, positive terminal, negative terminal, current is flowing here. So positive, negative, current is flowing, bulb is glowing. Okay, if the current is flowing, I is flowing, that is current. So a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. Here you see, so it is a closed path, current is flowing. Okay, continuously. Okay, so a continuous and closed path of an electric current is known as an electric circuit. Okay, here there are two types. One is conventional current, and electric current. Second one is electric current. Okay, so electric current. So 1 mark, for 1 mark, these 2 points are very important for 1 marks. Okay, for 1 mark. Okay, so 1 mark question. This is for 1 mark, and this is also for 1 mark. Okay, this is for 1 mark, this is for 1 mark. Conventional current. So what is conventional current? Conventional current is nothing but, so the flow of positive charges. Is known as conventional current. The flow of electrons is known as electric current. The flow of positive charges. Positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal. Once again, positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Conventional current is nothing but flow of positive charges. So flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Flow of positive charges is known as conventional current. Flow of electrons is known as electric current. The flow of electrons is known as electric current. I hope it is very clear. Right? And here conventional current will move. Positive charges will move from high potential to low potential. Very, very important. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. I hope it is very clear. Just check once. Conventional current. Okay, positive charges will move from So positive charges will move from high potential to low potential, whereas electrons, so negative charges will move from low potential to high potential. So there is one question on this. That is, so will negative charges will move from low potential to high potential to low potential. Is it vice versa? So let me know. Like that, they will ask questions on this one. Okay, so make sure that you are preparing this one. So positive charges, compulsory positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Okay, I hope it is very clear, right? Yes. Next one we will discuss about potential difference and electrical potential. What is potential difference and electrical potential? Normally you can observe, current will pass positive terminal to negative terminal. I hope it is very clear. So current will pass from positive terminal to negative terminal, right? So electrons, positive charges are nothing but conventional current. Positive charges will move, negative charges, electrons will move from negative terminal to positive terminal. So that is one point. And coming to the next one, that is potential difference. What is the potential difference? Work done to bring unit positive charge from one point to another point within the conductor. So electrical potential and potential difference. Electrical potential and potential difference will discuss. Electrical potential and potential difference. Sir, I have one doubt, sir. So that is, what is the difference between electrical potential and potential difference? The question is, what is the difference between electrical potential and potential difference? So a very small difference, that is, electrical potential difference is nothing but the work done to bring unit positive charge from one point to another point within the conductor. Okay, electrical potential. Okay, so coming to electrical potential. Electrical potential. Electrical potential is nothing but work done to bring unit positive charge from one point to another point within the conductor. So I am taking here. So this is a positive charge. We are doing some work from point A to point B. This is a point A and point B. So we are doing some work to bring positive charge from one point to another point within the conductor. So V equal to W by Q. Okay. So here you can see here. So V equal to W by Q. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge flowing from. So here you can observe. What is electrical potential. Okay, potential difference, right? This is electrical potential. Electrical potential means work done to bring unit positive charge from infinity to the required field. Here a potential difference. This is a potential difference. And next one is electrical potential. So nothing else, similar one only, but a small difference. So potential difference means work done to bring unit positive charge from one point to another point within the conductor. Is called potential difference. 1 volt V equal to W by Q. 1 volt equal to 1 joule by 1 coulomb. Electrical potential is nothing but, so I am taking this the required field. So this is the charge. So infinity I am taking. So we are doing some work to bring unit positive charge from infinity to the required field. So this is the required field. Whatever we need, this is the field. To this field we need to bring. So the charge. So we are doing some work to bring unit positive charge from infinity to the required field. That is called electrical potential. Coming to the potential difference, work done to bring unit positive charge from one point to another point within the conductor. So W equal to V equal to W by Q. V is the potential difference. W is the work. SI unit of work is joule. SI unit of charge is coulomb. Okay. So this is about potential difference and electrical potential. Potential difference and electrical potential. So now I will explain one more point. So potential difference and electrical potential, I hope it is very clear to you all, right? Next one, I'll discuss one more point, that is Ohm's law. Will discuss Ohm's law. Ohm's law. So Ohm's law, very very important point. Ohm's law. Ohm's law is nothing but first one. So here this is the resistor. I am taking this is the voltmeter. Resistor, voltmeter. Okay. Now ammeter. So cell, positive terminal, negative terminal, current is flowing. So V is directly proportional to I. V equal to IR. So what is V? Potential difference. What is I? Current. What is V? Potential difference. What is I? Current. So the potential difference across a resistor, the potential difference across the resistor is directly proportional to current flowing through it. Okay, the potential difference across a given metallic conductor. So proper definition is the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. At a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a anyway at constant temperature, and physical conditions also. So physical conditions also. Okay. So V is directly proportional to I, V equal to IR, V equal to IR. Now you can observe. So this is about statement. Coming to the materials required. What are the materials required? So we need to take materials. What are the materials required? Materials required. First one is 4 cells. 4 cells of 1.5 volts each. See here you can observe. So 1.5, 1.5, 1.5, 1.5. So how many cells? 4 cells. So how many cells are there? 4 cells. Okay. Now second one is so nichrome wire. Nichrome wire is an alloy of nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay, so nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And coming to the ammeter. So and the next one voltmeter. And the next one, fifth one is ammeter, voltmeter. So 4 cells and nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an Li of nickel, chromium, manganese and iron metals. Meter, voltmeter. Next one, connecting wires. Shall we take connecting wires? So switch also there, right? Switch. What about switch? Switch is there. So here, switch I am taking here. Closed switch. Switch. And coming to the sixth one, connecting wires. Connecting wires. Sir, what is the process? The process is first one, procedure. So procedure, what is the procedure? The procedure is first you have to connect one cell, and note down the reading of ammeter and voltmeter. So connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Connect three cells and note down the reading of ammeter and voltmeter. And repeat the process for fourth one. So first one, connect one cell. One cell you have to connect. One cell and note down the reading of ammeter and voltmeter. So connect to two cells. You have to connect to two cells. Okay. So will you take two cells? I am taking two cells. Two cells you have to connect. Coming to the third one, 3. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Once again, so procedure is first you have to connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Right? Next one. Coming to the graph. So if you draw the graph, okay. So if you draw the graph for V and I, the graph is linear. The graph is linear like this. V on y-axis, I on x-axis. Okay. So the graph is linear. So for what? For which conductor? So ohmic conductor. The conductors which obey Ohm's law, those are called ohmic conductors. Are the circuits which obey Ohm's law, those are called ohmic circuits. Okay. Here these are ohmic conductors. Coming to the non-ohmic conductors. These are non-ohmic conductors. Non-ohmic conductor, the graph will become curve. So here non-ohmic conductors. Non-ohmic conductors, here ohmic conductors. Understood? So ohmic conductors means the conductor which obey Ohm's law, those are called ohmic conductors. Non-ohmic conductor means the conductor which does not obey Ohm's law, those are called non-ohmic conductors. Okay, so this is about Ohm's law. First of all, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. Metals required 4 cells, 1.5 volts each. And nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, switch and connecting wires. Procedure: first connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process. Ammeter and voltmeter means what? Ammeter is the current, voltmeter is the potential difference. Ammeter reading is what? Current. Voltmeter reading is what? Actual. So you can draw the tabular form. So tabular form is there, right? So note down the reading in volt tabular form. You can mention the tabular form. What is your tabular form? So I'll draw that also. So you can take like this tabular form. So serial number and number of cells, and coming to the ammeter reading, voltmeter reading, and V by I, that is nothing but R. So here R equal to V by I. So Ohm's law gives definition of resistance. So here how many cells we took? 4 cells. How many cells we consider? 4 cells. Okay, here 1, 2, 3, 4. 1, 2, 3, 4. And anyway, graph is same for ohmic conductor. Potential difference on y-axis, current on x-axis. The graph is linear. So ammeter reading is current. Ammeter reading is potential difference. V by I is R. V equal to IR. Okay, I hope it is very clear. Right? Next one. So, chalo, next. So, Ohm's law is completed. Resistance and resistivity. Resistance and resistivity. So factor depends on resistance. Factor depends on resistance. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to, so rho into L by A. R equal to rho into L by A. Rho into L by A. Okay. So rho equal to, what is that? RA by L. Is it clear? Rho equal to RA by L. What is the SI unit of resistance? Ohm. What is the SI unit of? So rho equal to RA by L. So SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. So then you will get ohm meter. So resistivity equal to ohm meter. Resistivity is equal to ohm meter. I hope it is very clear. So SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. So very important. Difference also differences. So resistance depends on length of the conductor. Resistance depends on area of the cross section. So resistance depends on temperature and material of the medium. So coming to resistivity, resistivity does not depend on length and area. Resistivity depends on temperature. Resistivity depends on material of the conductor. Yes? Yes. Right. Okay. Done. I hope it is very clear. So these are the points. Okay, so resistance and resistivity, Ohm's law completed. Next, resistors are connected in series, resistors are connected in parallel. So I will explain. Resistors are connected in series, resistors are connected in parallel. Then uh, uh, even if you what is the point? Okay, then come to the point. Resistors are connected in series. This is 1, 2, 3. So ammeter. So here you need to understand current is passing through R1, R2, R3. Current is passing through R1, R2, R3. Okay. So Is equal to I1 equal to I2 equal to I3 equal to I. Sir, why this much? Why Is equal to I1 equal to I3, I2 equal to I3 equal to I? Because so current through R1, current through R2, current through R3 is same. That is the reason we are taking entire the current. So entire the circuit, the current is same. The entire the circuit current is same. Okay, now so from Ohm's law, V equal to IR. So Vs equal to V1 plus V2 plus V3, because potential difference in the series combination is equal to V1 plus V2 plus V3. So IRS equal to IR1 plus IR2 plus IR3. Okay, so now I am taking I common R1 plus R2 plus R3. So I get cancel. RS equal to R1 plus R2 plus R3. So this is the resistance in series combination. Okay. So I hope it is very clear. So total resistance in series combination. If n number of resistors are connected in series, so Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. Right? I hope it is very clear. So current is same throughout the circuit. R1, R2, R3. Potential difference V1, V2, V3. Current is passing. Battery, ammeter, switch. So potential difference and resistors. So Vs equal to V1 plus V2 plus V3, IRs equal to IR plus IR2 plus IR3, IRs equal to I common R1 plus R2 plus R3, RS equal to R1 plus R2 plus R3, RS equal to NR, RS equal to NR, right? So I hope it is very clear, right? Next one. So coming to the next one, resistors are connected in parallel combination. So current is passing, whatever the current is passing through resistors, okay. So current will be divided into three parts, I1, I2, I3. So potential difference Vp equal to V1 equal to V2 equal to V3 equal to V. Potential difference is same. So current is different. V equal to IR. So I equal to V by R. Now Ip equal to I1 plus I2 plus I3. So in the place of Ip, shall I write? So shall I write V by Rp equal to V by R1 plus V by R2 plus V by R3. Okay, so we am taking common 1 by Rp equal to we am taking common still. So here also, here we have to take common. So 1 by Rp carbon plus 1 by R2 plus 1 by R3. So we will get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. I hope it is very clear. Resistors are connected in parallel combination. So this is the answer. So if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, so 1 by Rp equal to n by R. So Rp equal to R by n. That is the answer, right? Yes. Check once. Is it clear? Do you have any doubt? So let me know. So next one, heating effects of electric current we'll discuss. Heating effect of electric current. Okay, so heating effect of electric current we'll discuss. So heating effects of electric current. So now V equal to W by Q, W equal to VQ. So P equal to W by T, P equal to W by T. So VQ by T, that is nothing but V into Q by T. So Q by T is the current, that is nothing but the rate of flow of charge. So P equal to Vi. We know energy is given to the conductor. Energy is given to the conductor, that is nothing but P into T. So now H equal to, we know P equal to Vi. So substitute Vi into T, V equal to IR. V equal to IR. H equal to IR into I into T. So then H equal to I square RT. H equal to I square RT. Okay, so this is about heating effect of electric current. Heating effect of electric current. Now you check once. Now you can check once. Heating effect of electric current. So V equal to W by Q, W equal to VQ, Q by T is the current, P equal to power equal to electrical work. So electrical power if you are taking, so P equal to W by T, VQ by T, V into Q by T, Q by T is I, P equal to VI. So energy is given to the conductor equal to P into T, P equal to VI. So here H, whatever the energy is given to the conductor, that will be dissipated in the form of heat. H equal to Vi into T, V equal to IR into I into T. So that is H equal to I square RT. Okay. So short circuit is nothing but direct contact of live wire and neutral wire takes place. Heavy amount of current will be drawn from the mains. Okay. Next one. Overloading high voltage appliances on at a time. High voltage appliances on at a time. Heavy amount of current will be drawn from the mains. Okay. So this is about short circuit and overloading. Then that's enough. Live wire, neutral wire. Live wire is positive terminal, red insulation. Neutral wire is negative terminal, black insulation. Earth wire is green color. Live wire potential is 220. Neutral wire is 0. The potential difference between live wire and neutral wire is 220 volts. So in India we are using 220 volts. Okay. Potential difference between live wire and neutral wire. Live wire and neutral wire 220 potential. Okay. Potential difference. And so safety measures, we are using electrical fuse and earthing in our households. Electrical fuse and earthing. Okay, so if extra current goes in the circuit, fuse will melt and break the circuit. It safeguard the appliances. And coming to the earthing, so metallic appliances, any extra current is there, so that will send to the ground. So that extra current will send to the ground. That is earthing. I hope it is very clear. So thank you so much. So this is our Sir from Student D Brand. If you like the content, do like, share and subscribe to So if you like the content, do like, share, and subscribe to Student the Brand. This is your Siva sir. So thank you so much for joining and attending and listening my class. So we'll see you in the next class with a different topic. We'll see.